Hello, we're going to go through and do the review for Chapter 5 quiz together. If you have any questions, please make sure you're asking. Also, if you went through and started it and you have some of it done, just fast forward to the problems that you don't know how to do. So for the first problem, it says, please write in standard form, then classify by the degree and the number of terms. So standard form, don't overthink standard form. They just want you to rearrange the terms from highest to lowest in terms of the exponents. Any like terms, you want to combine those together. So for the first problem, the 7m to the fourth, we're going to put first, then plus 4m squared, then minus m. So notice our exponents are highest to lowest. And then once we have it in standard form, they want us to tell what the degree is. So our degree is our largest exponent, so it's just 4. And then how many terms are there? So our terms are how many groupings are separated by a plus or a minus sign. So this is 1 term, 2 terms, 3 terms. Alrighty, let's try another problem. For the second one, that f of t, that is a function notation. If you don't like that, you can just put y equals. And then again, we're rearranging the exponents highest to lowest. So we have 3t to the third power. This 4t and 2t are like terms, so we're going to combine those. So we get 6t and then minus 7. We have it in our standard form. Our degree is our largest exponent, which is 3, and our number of terms, there's 1, 2, 3 of them. The next problem, same idea. We have 2r to the second power plus 5r plus 7. There were no like terms, so we couldn't combine any in this one. Our degree, our largest exponent, is 2. And then the number of terms on this one, there is 1, 2, 3 terms. For the next section, it says find the zeros and then state their multiplicities. For this, they already have them factored, so they were nice for that aspect. We're just setting them equal to 0 and then solving for them. So we get x equals -2 here, then x equals +5. So if we were to graph this problem, it's going to cross the x-axis at -2 and +5. And then the second part of the question, it says state their multiplicities. So that you're just looking at your exponents. And this -2, we're going to put underneath of it that it has a multiplicity of 2. This +5 then has a multiplicity of 4. The next one, again, we set our parentheses equal to 0. We solve for each equation. So we get x equals -2/3 and x equals +5. And then we need to state their multiplicities. So this one, if we go back to our exponent, it has an exponent of 3, so the multiplicity is 3. And then this one has a multiplicity of 5. This next one, we would set all 3 of these terms equal to 0. So we would have x squared equals 0, x plus 4 equals 0, and x minus 1 equals 0. So this, we get x equals 0, x equals -4, and x equals 1. And then we set them, once we're done setting them equal to 0 and solving for them, we look at the exponents. This one has a multiplicity of 2. This one has a multiplicity of 3, and this one doesn't have an exponent, so we could put to the first power, so it has a multiplicity of 1. Make sure for the multiplicities, you're never going to have a multiplicity of 0. That means that solution doesn't exist. This next section, it says divide using synthetic division. So what we're dividing by, we're going to set equal to 0 and solve for it, so we get x equals 1. So that number goes in our box. And then from here, we're going to look to see if it skips any terms. Do we need to put zeros, any placeholders? So it goes 3, 2, 1, and 0. Doesn't, so we just put our coefficients. So 1, 3, -1, and -3. We drop that first number. It doesn't matter what it is. That's our starting number. Multiply our diagonals. Add our columns. Multiply our diagonals. So 4 times 1 is 4. Add our columns. So we get 3. Multiply these diagonals, we get 3. Now this last number is always going to be your remainder. So our remainder for this problem is 0. And then we either can count our way upwards for our exponents. So this would be 3 and then x to the 0 power, which we don't need. then 4x to the first power, and then plus 1x to the second power. Or think this is to the third degree, so the exponent is going to be 1 less. So second, then 1, and then 0. But that last number is always going to be a remainder. For this next one, we set this equal to 0, we solve for it, we get positive 4, so 4 goes in the box, goes 3, 2, 1, and 0, doesn't skip a term, and then we go through and drop that first number, multiply, add, multiply, add, multiply, and add. And this one doesn't have a remainder either, so started with 3, so this is going to be 1 less, so 2x to the second power, plus 5x, plus 2, and then the remainder is 0. You can put a remainder of 0, or if it has a remainder of 0, you don't need that. Let's go to the back side of the review. For 9, 10, and 11, this was from section 5.3. This was the most challenging for most students. Make sure, bare minimum on the quiz, at least graph it, find the real solutions. If you can't find the imaginary ones, at least I can give you partial credit. So for the first one, if we want to take a look at the degree, the largest exponent is 4. So I know off on the side I'm going to have a total of 4 solutions. Okay, so right from the start, my options are I can't use the quadratic formula. It's not to the second power. So I can either factor or I can graph it. Are my 2 choices. So if I take a look at the graph, go to y equals x to the 4th power plus 14x to the second power minus 32. Click graph. I'm looking to see where does the graph cross the x-axis. So it crosses at 2 different places. Notice it decreases right through here, increases right here, through here. There's no turning point, so they just have a multiplicity of 1 and count as 1 solution each. So there's 2 real solutions, so the other 2 have to be imaginary. So I'm going to go to second trace. I'm going to go down to 0. Okay, and I couldn't find my cursor. So with that, notice right here it crosses between -1 and -2. So the -2.9 would be to the left of it. Click enter. Then we're going to go somewhere around -1. And then that would, oh, there it is. And then click enter, enter. And I get -1.4. So then I'm going to go second trace, 0. Then I'm going to go over here. And I go to the left of it, click enter, go to the right, click enter, enter, I get positive 1.4. So like I was saying, if you can at least get the 2 real ones for this problem, you'd get some partial credit. If we keep going, now we're going to have to factor it. So we make our parentheses. Our leading term is x to the 4th, so we're going to need x squared times x squared to give us that x to the 4th. Then to take our a, which is 1, our c, which is -32, we're going to multiply those, and we have to see what multiplies to -32 but adds up to 14. So we have 1 and 32, 2 and 16, 3 doesn't, 4 and 8, 5 and 6 doesn't. So those would be our combinations. It has to multiply to -32, so 1 positive, 1 negative, but add up to 14. So positive 16 and -2. So then I throw in that combination. And at this point, my options are, now they're both in quadratic form, so I can use the quadratic formula here, the quadratic formula here, to get my 2 solutions here, to get my 2 solutions here. So if I like that quadratic formula, that is an option. Another option, I can just set it equal to 0 and solve for it. So let's do maybe that option. So then I add my 2 to both sides, so x squared equals 2. Take the square root, so I need x equals plus or minus the square root of 2. Okay, and this square root of 2, if I simplify it, it's just 1.4, so that's how I'm getting these top 2 solutions. Now I'll set this next one equal to 0, so I have x squared plus 16 equals 0. So x squared equals -16 when I subtract 16 on both sides. take the square root, so I get x equals plus or minus. The square root of 16 is 4, and a negative underneath there, so I have my I. So then I have a positive 4i and a negative 4i. So then I have my 4 solutions. This next one, number 10, again, I can go ahead and graph it and hope this one has 3 solutions because my degree is 3, that all 3 of them cross the x-axis. So we'll take a look at it. Okay, so this one looked out, crosses at 3 different places. There is a total of 3 different solutions. So this one, just by graphing, I could be done. So I need to figure out where it crosses the x-axis. It looks like it's going to cross at negative 4, 0, and positive 4. If I'm not sure, I can go to second trace 0 and do the left bound, right bound. To the left of it, to the right of it, and it does cross at negative 4. And then it crosses through 0 and positive 4. So those would be my 3 solutions. And I would be done. There's no imaginary ones on this one. If I do not like the graphing method, another method I could do is by factoring. So notice an x goes into both of those, so I can factor out an x. Then I have x squared minus 16 left over. And then I can either see that this has no middle term, and so I could set that equal to 0 and solve it like I did over here. Or I could see that it's a difference between 2 perfect squares and it factors further. So I have square root of x squared is just x, square root of 16 is 4. No middle term means 1 positive and 1 negative. And then just set each of these equal to 0. And I would get the same solutions as graphing. Alrighty, the last problem. Let's go ahead and maybe graph it. So I have 6x to the third power minus 2x to the second power plus 4x. This one, the degree is 3, so there's going to be 3 different solutions. Notice for this one, there is a curve right through 0. So 0 is going to be a solution. Okay. So then I can't use the quadratic formula yet, so I'm going to go ahead and start factoring, sorry. So I'm going to factor out a 2 and an x. I have 3x squared minus x plus 2. This is how I got that 0 if I'm doing it by factoring, so x equals 0. The degree is just 1 because of the exponent. There's no multiplicity on it. And then this part, I could try to factor, but most likely it's not going to factor just because those weren't real solutions, so they're probably going to end up being imaginary. So you should probably use the quadratic formula. So my a is 3, my b is negative 1, and my c is 2. So I have x equals negative 1, so just 1 plus or minus negative 1 squared, which would be positive 1, minus 4 times my a times my c, all over 2 times my a. Then I go through and simplify it, so 1 plus or minus 1 minus 4 times 3 is 12, times 2 is 24. 1 plus or minus 1 minus 24 is negative 23. I cannot leave a negative underneath my radical, so I'm going to bring out an I and force that to be positive. So then that would be 2 of my answers because of the plus and minus sign, and then the 0 was the other one. So I'd have 1 plus or minus I squared root of 23 divided by 6. And then I have found all 3 solutions, so then I'm completed with that problem. Alrighty, number 12. We can do this one 2 different ways. So one way is they're telling us x equals negative 4. So I could just substitute that in for my x's and then simplify either using order of operations or PEMDAS. So then, or I could just use my calculator. So I plug in 4, negative 4 for all my x's. and then I simplify it down, I get a number, and then I would be completed. If you don't have a graphing calculator on hand, another way that you could do this, just use your synthetic division from the front side of the review. That this x equals -4 goes in the box. Don't switch the number because the x is already solved for. It goes 4, 3, 2, it skips 1, so we're going to need a 0 there as a placeholder. And then whatever the remainder is that we're getting, that is going to be our answer. So 49 times 4. So 783 is the answer that we're going to get for this problem. Either way, whether you're doing it by using PEMDAS in the order of operations up here, or if you're getting your remainder here. Alrighty, the next problem, it wants you to write the equation. These are the two solutions. So make sure if we're working our way backwards, we're just plugging in the opposite. So we have y equals x, and then we put in +3, and then -2. I will accept just leaving it in factored form. If you want to put it in standard form, I would accept that answer also. So x times x squared, x times -2, -2x. Now distribute the 3, so we get a positive 3x and -6. Combine our like terms, and I would accept this answer. Last problem, we need to go ahead and factor this. It says the volume of a box is x to the third power plus 4x squared plus 4x. Explain how you know the box is not a cube. So if it's a cube, all the length, the width, and the height are all the same. So if we factor this, all three of the dimensions are the same, we know it's a cube. If we factor it and all three dimensions are not the same, then we know it's not a cube. So this one, an x factors out of all of them, so we factor that out. The exponents are just reduced by 1. So we leave that, and then we factor this part further, so we have x and x. We take our a times our c, we get 4. So we have to figure out what multiplies to 4, but adds up to 4. So we have our 2 and our 2. So these would be our three different dimensions, our length, our width, and our height. Notice they're not all three the same, so this is not a cube. And you could just explain that all three dimensions are not the same. If they're all three x plus 2, then we'd say yes, it is a cube.